You know those classic word problems from school? The ones about two people painting a fence or pipes filling a pool? They can be a real headache. But what if I told you that you already know the secret formula to solve every single one of them? Seriously, you already have it memorized. Okay, let's start with something super familiar. I'm talking about this formula right here. Distance equals speed times time. We all learned this, right? It's how we figure out road trips. It's simple, it makes sense, and it feels like a totally different universe from work problems. But that's the big question, isn't it? What on earth does driving a car have to do with two people painting a fence? One's about speed and highways. The other's about, well, chores. They seem like they're from totally different planets. But here's the crazy part. They're not just similar, they are exactly the same. That's the big secret we're gonna uncover. The key to cracking these work problems isn't learning a new formula, it's seeing the hidden connection. And trust me on this, painting a fence is, mathematically speaking, the exact same thing as driving a car. Let me show you how. And this is the whole trick. It's all about a simple shift in how you look at the problem. We tend to focus on the work itself, one fence or one pool. But that's not what matters. The key is to focus on the speed of the work. Now, there's a fancy word for this, productivity. Or a simpler one we'll use is rate. It's just a way of saying how much stuff you get done in a certain amount of time. How many pages you can read in an hour, or how much of a fence you can paint in a day. It's basically your work speed. Okay, get ready for the aha moment, because this is it. Look at this comparison. For motion problems, we have distance, speed, and time. For work problems, well, distance is just the total work you need to do. Speed becomes productivity, our work speed, and time, well, time is just time. The formulas are identical, so that means work equals productivity times time. It's the same formula, just with different labels. So now we've got our formula down. A equals P times T. Easy enough. But where these problems get really interesting is when you add more people. Teamwork! And the best part is, all of it, every single team problem, boils down to one incredibly simple rule. And here it is. This is the golden rule, the master key that unlocks everything. When several workers cooperate, their rates add. That's it. That one sentence is all you need to remember. So let me say that again, because it's that important. To figure out a team's combined work speed, you don't do anything complicated like averaging their times. Nope. You just add up their individual speeds. You add up the rates. It is literally that simple. All right, theory's cool and all, but let's see this thing in action. Let's go back to that original fence problem I mentioned and actually solve it together. So here's the setup. We've got Alex, who can paint a whole fence in 5 hours. And we've got Jordan, who takes a little longer, 7 hours. Now, common sense tells you that if they work together, they've got to be faster than Alex, right? But how much faster? We're going to knock this out in 3 easy steps. First, we need to find their individual work speeds or rates. If Alex paints one fence in 5 hours, then every hour he paints 1/5 of the fence, so his rate is 1/5. Same logic for Jordan. His rate is 1/7 of the fence per hour. Step 2, add them up. We just add their rates together, so 1/5 plus 1/7 is their combined work speed. And finally, step 3, we find the time. We just flip our formula around. Time equals the total work divided by their combined rate. Since the work is just painting one fence, it's just 1 divided by that rate we just calculated. You run the numbers, and what do you get? About 2.9 hours. So just under 3 hours for the whole job. And check that out. That's way faster than Alex could do it alone in 5 hours. The math proves it. Teamwork really does work. Okay, so adding rates together when people are cooperating, that makes perfect sense. But what's really cool is that this same idea can handle even trickier situations. What happens when you have forces working against each other? Like those classic problems with one pipe filling a pool while another one is draining it at the same time. Well, the idea is actually pretty intuitive. Some work is positive. It helps you reach your goal, like a pipe filling a pool. It's adding water, so its rate is positive. But a pipe draining the pool, that's taking water away. It's working against you, so we just call that a negative rate. And here's the beautiful part. Our golden rule, just add the rates, still works. You don't have to change anything, you're still adding them all up. It's just that, well, adding a negative number is the same thing as subtracting. So you take the positive filling rate and you add the negative draining rate, and that tells you exactly how fast the pool is actually filling up. It's so elegant. So let's boil this all down. What are the big takeaways here? First, remember that work problems are just distance problems wearing a disguise. Second, the secret ingredient is always the rate. Focus on the work speed. Third, when people are working together, you add their rates. And finally, when they're working against each other, you guessed it, you just subtract the negative rate. Easy.
And that brings us to one last thought, a bigger one. Because this isn't really just about math problems, is it? It's a perfect model for how collaboration works in the real world. So just think about it for a second. Where in your life, at work, in your hobbies, on a project, where could you combine your rate with someone else's to get something amazing done way faster than you could on your own?